So I took a wild extrapolation and said, we're going to continue doubling every year. We're going to go from about 60 elements now to 60,000 in 10 years. And I was just trying to get across the point that this was the direction semiconductors were going, and it was going to give a tremendous cost advantage, which wasn't true at the time. The early integrated circuits cost quite a bit more than the pieces to assemble the similar circuits out of individual components. But one could see the trend was going in the direction that this was going to be the cheaper way eventually. That was my real objective, was to get the idea across. We have a technology that's going to make electronics cheap. But I didn't expect this 10 order of magnitude or binary order of magnitude increase, the 1,000-fold increase in complexity, to be very accurate. I just thought it was a general trend we were going to have, but in fact it was far more accurate than I could have anticipated. One of my colleagues, I believe it was Carver Mead, a professor at Caltech, dubbed this Moore's Law, a name that has stuck beyond anything that I think could have been anticipated. It was one of these articles that appeared in one of the trade magazines. You know, I wrote it as a technical paper, and fortunately we had an editor who lightened it up considerably. The industry has been phenomenally creative in continuing to increase the complexity of chips. It's hard to believe, or at least it's hard for me to believe, that now we talk in terms of the billions of transistors on a chip rather than tens, hundreds, or thousands. Certainly, the impact the so-called Moore's Law has had has changed over time. In the beginning, it was just a way of chronicling the progress. So it went from a way of measuring what had happened to something that was kind of driving the industry. When Intel started, the total market for transistors, as I recall, was something less than 1 billion. Now we put that many on one chip. It is an industry that is unmatched in how it's been able to evolve and decrease costs. The first transistors that we sold at Fairchild were $150 a piece. Now a transistor in one of the modern integrated circuits, the cost is measured in microcents, less than 1/1,000,000th of a penny per transistor. This idea, which has subsequently been called the microprocessor, was certainly intriguing in that it moved Intel in a completely different direction. Of course, at that time, we had no idea of how important that direction would prove to be, not only for the company, but really for industrial society in general. This phenomenon happened not only in personal computers, but across the entire area of distributed data processing, especially the office automation area, and much of the rest of the electronics industry.
The new screen and the Pentium processor are much better.
When Professor Hawking was in Silicon Valley last year, we saw he was using rather obsolete technology on his wheelchair for his computer system. We had the opportunity to upgrade it to something more nearly representative of the state of the art. We think we've increased his ability to do his research work as a result.